So far I have discussed the logistic regression. Now it's time to discuss how what are the metrics to evaluate the classification model, right? So can we use accuracy for predictions for classification task? The simple answer is no. Why no? Let us observe that. So let's say there are 5 examples from the previous thing. Let us copy this first. Where is, yeah. Mm. So let's say we have this kind of sample where my model predicts this correctly, this incorrectly, this incorrectly, this is correct, this is correct. But these two incorrect mistakes, do incorrect predictions. So is the mistake saying class 1 being predicted as class 0 and 0 class being predicted as class 1? If I use the accuracy, I will not be able to classify uh, my model is if my model able to no I will not be able to classify these two mistakes separately. So let's say for an why accuracy will fail, let us first discuss that, then we'll come to this later. First we'll focus on why for an imbalanced data set. Why? Let's say imbalanced data set, we have 90-10 ka ratio where 90% are my class 0 and 10% are my class 1. Now if my model, let's say I have built a very mode model is something like, if I take the mode of my y values where 90 there are 91s and 0 10 tens, zeros are 10, ones are 90. So if I take the mode of this, the mode would be 1. So if my model learns nothing and predicts every value as 1, sorry, here I've done the opposite thing here. So 90 are my zeros and 1 is the 10. So if I take the mode of this, I'll get 0. So if my model learns nothing and outputs 0 for everything, the accuracy will still be 90%. Yes, so the accuracy will still be 90% for the mode model, which is my the dumbest model ever. So I cannot predict whether my model is able to detect the class 1 at all, right? So let's say my class 1 is rainy and my model predicts everything as sunny. So the model is not able to create a line where the sunny is being classified as sunny. The model is not able to learn properly. So accuracy cannot highlight those mistakes. So we need a separate kind of metric which highlights the mistake where how many my model is able to detect this class 1 at all or not, right? So remember there's mistakes. So mistake, we need something that whenever my model does some kind of mistake where 1 is predicted as 0 and 0 is predicted as 1, we need to separate this out. So we have TP, FP, TN and FN, right? So FP belongs to when 0 is predicted as 1 and FN is 1 predicted as 0. So 0 predicted as 1, 1 predicted as 0, right? Both are separate mistakes. That's it. And both are crucial mistakes also. So if I build a simple confusion matrix out of this, my confusion matrix would look something like this. Right? Let us understand this, what is TP, TPFN and whatever. What is this TP, FP, TNFN? What is all this? We are not considering the correct predictions at all. We are just focusing on FP and FN. So FP is my precision. So let's say if a model is, let's say assume an umpire for a cricket match for an example. So for false positive, so let's say when a opposing team appeals the umpire and umpire has to decide whether it's a out or not out for an LBW. So if what is the prediction accuracy? So if the number of times you know the umpire has given positive class is, let's say, out, how many times it was actually out. So this is predicted out by actually out, predicted by actual, right? Just the positive class, we are only concerned about the positive class, right? Deciding out not out without appeal on every ball. Let's say there is no appeal going on, but if my umpire able to detect whether it's an out or not out for an LBW without an appeal every ball. So the classifier, which is called the classifier detection accuracy, which deals with the false negatives. The false negative means the actually it was positive, but then so the umpire out of times, out of the total number of times it was out, number of times the batsman was out, how many times the umpire have given out. Let's say there were 3 chances that the batsman was out, but it has only given out the one time. So this is not the actual formula, so the number should not match up, it is just an analogy. So like umpires, what is the umpire's detection accuracy? If the batsman is originally actually out, so is my umpire able to detect the batsman is out or not, and which is called the recall. And if umpire gives out a positive class, how many times it was actually positive, so it is considering the false positive, and here we are considering the false negative, right? So precision formula becomes the TP upon TP plus FP, and because we are considering the false positive, the total number of time given positive, how many times it was actually positive, the total number of times given positive, how many this is the detection accuracy, where the total number of times the prediction was correct. So prediction was class 1. So here we are looking as TP plus FN, TP and FN. Here we are looking at this is recall, and when we look horizontally, like vertically, this is a precision. Both focuses on the true positive, but considering the false positive here. This is the predicted precision accuracy, and the actual detection accuracy. This is precision accuracy, this is the detection accuracy, because this is the predicted class. Out of the total prediction, how many predictions were correct, out of the total actual correct, how many were detected. So we look the horizontal. Yeah. So F1 score is just the balance between precision and recall. It is just the harmonic mean between precision and recall. So it becomes 2 into precision recall upon precision by recall. Why harmonic mean? Because you know, the simple mean doesn't penalize the imbalance between precision and recall. So let's say we have to select an umpire. So we'll generally look at the F1 score of the umpire. How many times what is the precision of the umpire and what is the recall of the umpire? Both should be high. Reflection accuracy and prediction accuracy for an umpire to be a good umpire. Right? Now, what are the limitations of the matrix? There are no limitations of the matrix, but it is just a reflection of the original data. So if the original data should be heavily dependent, the confusion matrix is a reflection of historical data after using a threshold. So let's say if I am applying, my model is applying some threshold and we are building a confusion matrix out of this, right? And this reflects the original data only. The original data should be correct. This is the only limitation that it has. Thank you.